Hey, what's up guys? It's Mr. Bella. We're going to be doing geometric figures today, continuing in that chapter. And with that, we're going to be doing scale drawings and finding a scale factor. So let's get into it. Okay, first of all, there's going to be a lot of vocabulary. Scale drawing, scale model, scale, and scale factor. Scale drawings and scale models are used to represent objects that are too large or too small to be drawn or built to actual size. So scale drawings, scale models, if you think of like a Lego piece or Hot Wheels or a map, blueprints of anything, those use scale drawings and scale models. So they usually, if you're trying to build, let's say, a small shelf, like about this big, you might not need a scale drawing or something, right? Sometimes you would have drawings where you have the part and you lay it flat on a mylar sheet and you just take the dimensions there. It's supposed to be exactly the same. But sometimes if you're building something like a phone, you're going to need something that shows the components inside the phone a lot bigger than what it really is inside. Because if you actually open up a phone, there's going to be very small components there, kind of hard to see where everything goes and how everything's set up. Same goes for if you're building a house or the gym or the STEM lab or something, right? You're going to want, it's going to be a big piece of paper, but it's not going to be as big as the actual floor plan of the gym or the STEM lab. It's going to say, it's going to be like, there's going to be a key or a legend, and it's going to say, well, from here to here, this inch represents 1 foot in the most general of terms. All right, so that's where scale drawings and scale models are used. And the scale actually gives the ratio that compares the measurements of the drawing or model to the measurements of the real object. That's different. So scale models, scale drawings, those are things that represent another object. The actual scale is a ratio. So that's what I said earlier. It was 1 inch on this drawing represents 1 foot in real life. The measurements on a drawing or model are proportional to the measurements on the actual object. So when we say things are drawn to scale, if you're drawing a car, I'm gonna draw like a car like that. I mean, that's not a very good car, right? But the wheels are like that, it's kind of low, whatever. It's kind of to scale, as opposed to something so everything's proportional. How tall it is proportional to how wide it is. Something that's not proportional is maybe like, that's very unproportional. I don't even know what's going on with that. That looks more like a camera or like a frog or something than with something on its head. I have no idea what that could be. Not a car though, so that's something else, not drawn to scale. I'm just going to erase that because I don't want that frog looking at me. Let's move on and see what some of these things are used for. So some of the things would be using Google Maps. It's great to see your house or your school or your city on the lower right or left hand side, I can't remember. If you're going in there, it'll show a little scale that's moving in. So maybe on the Mr. Bella, when you're editing this, put in Google Maps and show how you're scrolling or zooming in and out and show what the scale looks like there. Because if you have a regular map that's static, it's like a paper map or something, it'll show the scale or the legend at the very bottom showing from here to here, this is 1 mile. And you can use a little compass, not the kind that points direction, the compass that makes circles, or it takes measurements, and you can measure out how far a distance is. So let's take a look at this example here. What is the actual distance between Hagerstown and Annapolis? So this is an example out of the book. But the first step you would need to do is to actually measure with a ruler. Because if you had a map, like a physical map, you would measure out how far it is. From here to here, it says that the map distance is about 4 centimeters. All right, there we have one part of it. So if you wanted to find the actual distance, you would use this right here, the legend. So 1 centimeter equals 24 miles, and use the fact that on the map it's 4 centimeters. So we can write a proportion. Over 24 miles. So I'm just going to make sure, okay, 1 centimeter is the actual map. So this is the map, over whatever the actual distance is, the real distance. So actual. So that helps me write my proportion. So on the top is going to be the map, on the bottom is going to be actual. So on the map here is 4 centimeters, so I'm going to write 4 centimeters on top, and I don't know what the actual distance is. That's what I want to know, so that's going to be my x. All right, so that's a proportion, and if you forgot how to do that, you cross multiply and divide, or in this case, you can just see from 1 to 4, how do I get from 1 to 4? You multiply by 4. So here, I'm going to have to multiply 24 times 4, which is going to be 96. And then don't forget the correct units. On the bottom, this map is the actual distance, so that's 96 miles. So number 2, a graphic artist is creating an advertisement for this cell phone. If she uses a scale of 5 inches equals 1 inch, what is the length of the cell phone on the advertisement? So we're going to have to assume that they're making it bigger, like for a billboard or something. So here it says 5 inches, so we're going to say ad over real or actual. Okay, so the ad is 5 inches to the real, which is 1 inch. All right, so we're going to make a proportion here. Here, the measurement on the actual phone is given as 4 inches. So that doesn't go on top, it goes on the bottom, because we said that the real goes on the bottom and top is ad. So then that means the top is going to be the unknown. So same thing. You could have also done cross multiplying like you have done in the past. So if you wanted to do cross multiplying, 5 over 1 equals x over 4, you would cross multiply this way. So 1 times x is just x, 5 times 4 is going to be 20. And then especially for these, do not forget the units. I know they both say inches, but it's very important that you put the inches. So length of the cell phone on the advertisement is going to be 20 inches. Okay, maybe not a billboard, maybe just like a big print ad or something. All right, moving on. Okay, so right here it says find the actual distance from LA, Los Angeles to Houston. All right, so let's say the legend says right here 1 inch is equal to 300 miles. That's what you're going to see on a real world map or even in Google Maps. If you measured it out, which they already did for you, that's 1, 2, 3, 4, 5 inches. 1 inch is to 300 miles. So I'm going to say the map over actual. It's going to be map over actual. So that means the map here is 5 inches from LA to Houston. So it's about what? How many miles there? So 1 times x is just x, and 300 times 5, and 300 times 5 is going to be 1,500. And don't forget to put the units 1,500 miles. All right, cool. Moving on to something else. We have a Speedster here. It looks like a Porsche, I guess, like a really nice, cool old one. Here we have, it looks like a model. Okay, the scale here shows that 2.5 feet in real life is 1 inch on this model. And they show a little ruler, and I've shown the measurements here as we have 4 inches and 1 1/4 inch. Okay, so what's the actual length and width? So this actually means we have to do 2 separate calculations. So let's work with how long the car is. This is like how long and how tall it is. So length, I'm going to say the scale is 1 inch to 2.5 feet. So that means this is the model, and then this is the actual. Okay, not very neat, but let's zoom in there. All right, and so the length on the model is shown there as 4 inches, so that has to go on top. And the bottom is going to be x. So same thing, I'm going to cross multiply here. 1 times x is just x, and 4 times 2.5 is going to be 10. And then, not inches, we're talking about how long it is in real life, it's going to be 10 feet. So now the width, or the height of it, we'll call it width, in this case, the scale is still the same. It doesn't change. So the left side of your equation is going to stay the same. So I'm going to say 1 inch to 2.5 feet, okay, is equal to, the model is 1 1/4 inches. It's kind of weird that this is a decimal over here and this is a fraction. So I'm just going to make 1 1/4 into a decimal. So 1/4 is 0.25. So I'll just say that the model is 1.25 inches, and that's going to be x. So same thing, you're going to cross multiply. X times 1 is just x. 2.5 times 1.25 is going to be 3.125, and that's going to be feet. And if you memorize any of those, 3.125 is 3 1/8 of an inch. Okay, we didn't talk about scale factor, but here, scale factor is a scale written as a ratio without units in simplest form. So that means you're not using units, which means you have to have the same units. Find the scale factor of a model sailboat if the scale is 1 inch to 6 feet. So scale factor would just be, you take the scale, which is 1 inch to 6 feet, and it has to be in the same units. So that means both of them either have to be inches or they have to be feet. So whichever way you want to do it. It's probably easier if you make all of them inches, because I don't really want decimals. So in this case, 1 inch, that stays the same, because these are supposed to be equal. And then you have to figure out how many inches are in 6 feet. Well, there's 12 inches in 1 foot, so 6 times 12 is going to be, so 6 times 12 is going to be 72. And then this is inches. Now that you both have inches to inches, your scale factor is 1 to 72. Or it could be written as 1 to 72. So 1 of whatever way you're measuring it, even if you're measuring it in centimeters or feet or inches or whatever, that's worth 72 in the other thing. So that means you don't need the units. Like, let's say you're measuring it in meters, you don't have to worry about meters. You just know that the scale factor is 1 to 72. Right here it says 1 inch represents 3 feet of the actual. So that's our scale. Not the scale factor, the scale. Now it's saying, what is the actual area of bedroom 1? So we're not going to worry about anything else. It gives us a lot of information. So bedroom 1 is right there. And if you can't see, I could just draw it out over here. It is 4 inches that way and 1 inch that way. So I'm not going to multiply anything yet. I am going to change all the inches and dimensions to feet. Okay, so I'm going to worry about how long it is first. 4 inches. So right here, we're going to use the scale. So 1/2 inch, so I'll use a fraction, over 3 feet. So this is the plan over actual. So on the plan, it's 4 inches there. And how many feet is it? So we're going to do some cross multiplying here. Okay, so 1/2 times x, so 1/2 x equals 4 times 3 is 12. And then you're solving a one-step equation here. To isolate x, you multiply by the reciprocal of 1/2, which is 2 over 1. So x would be 24. So this would be 24 feet. So over here, I'm going to write this is the same as 24 feet. Okay, so that's the length. Let's worry about the width. So the scale stays the same. 1 inch is to 3 feet, so it's 1/2 of an inch is to 3 feet, as 1 inch here is to x. Okay, so maybe you can kind of do that in your head. So from 1/2 to 1, you just multiply by 2. But for the sake of, if you don't know, let's go ahead and cross multiply. So this is 1/2 x equals 3. And then same thing, you multiply by 2 on both sides to get 6. And this is 6 feet. And let's be safe, I'll write 6 feet here. All right, so we have all that so far. And now it's asking for, that's not asking for the dimensions. It's actually asking for what is the actual area. So the area on that, you can see 4 times 1 is just 4. You don't just multiply it by 6. You don't multiply the area by 6. And so the area equals the length times the width, and in this case we have 24 times 6. And that's going to give you 144. And then don't forget the units. It is in feet, because we're using feet here, and it's area, so feet squared. So 144 feet squared. Okay, so that's it for this lesson right here. Hopefully that helps, and I will see you guys next time.